Woohoo! Welcome back. Tonight we're going to be talking about a topic that isn't usually brought up in algebra classes, but I think is a really cool concept and it will help you with imaginary numbers. So woohoo! Let's talk about modulo. Modulo, or mod, if you're cool, we just call it mod, is the mathematical term for finding the remainder. And this is a concept that we use in math. We also use a lot in programming, and there are other applications, but tonight I'm just going to be talking about the applications for imaginary numbers. So the actual definition is a little bit cumbersome. A modulo B is the remainder you get when dividing A by B, which if you're like me, your brain is like doing little circles there. So basically, if you divide B into A, you'll get some answer, who knows what it is, and then you'll get a remainder. And it's this right here that we're interested in. We're interested in the remainder part. So let's just go through a couple of examples so that I can give you the idea. So right off the bat, if you look at 2 modulo 4 or 2 mod 4, that's 2. And then a lot of people say, what? Okay, let's do it. If we're going to divide 4 into 2, well, 4 is bigger than 2. So the answer is it doesn't go in at all. And 0 times 4 is 0. And the remainder is 2. So if you are looking at 2 modulo 4, and if the first number is smaller than the second number, then it's just whatever it is. So what does that mean? 3 modulo. So when you divide 3 by 4, well, 3 is remainder. That's what's left over. Why? If you do 4 into 3, well, it doesn't go. 4 is bigger than 3, so it goes 0 times. 0 times 4 is 0. And your remainder is 3. Now, things get interesting when we talk about 4 modulo 4 or 4 mod 4. Then we've got, where should I write it? I'll do it right here. 4 into 4 goes once, right? And there is 0 remainder. So 4 mod 4 is 0. There's no remainder. It goes in completely. And that's it. Okay, so now let's talk about some more interesting ones. Dun, dun, dun. So what about 15 mod 4 or 15 modulo 4? Okay, so let's come over here and we'll do, so remember 15 is the one inside, right? It's the inside the division sign, the dividend, thank you. And we're dividing it by 4. So we say, okay, how many times does 4 go into 15? Well, not quite 4 times. It goes 3 times, right? 3 times 4 is 12. And we have 3 remaining. And that number right there is 15 mod 4. So it goes in 4 times. It goes in 3 times, and then there's 3 left over. Okay, what about 16 modulo 4? Well, 4 goes into 16 how many times? 4 times exactly. And how much of a remainder is there? 0. So here, 16 modulo 4 is 0. And 37 modulo 4, let's try that. So 37 goes inside the box, 4 goes on the outside. 4 goes into 37, it turns out 9 times. 9 times 4 is 36. And what's our remainder? Our remainder is 1. So it's kind of interesting because in a lot of times in math, people get fixated on the first number. How many times does it go in? 9 is what's important, and the remainder is not important. With modulo math, we only care about the remainder. We only care about what's left over. And the reason this is going to help us is because when we're working with imaginary numbers, I'll remind you that I to the 4th equals 1. And this comes from, let me see if I can find the notes at the very beginning. This came from the work we did in the very first video when we talked about the circle, and we've got I and I squared and I cubed, and we got around to I to the fourth, and that equals 1 because it's I squared times I squared, or a -1 times a -1, which is 1. So every time we get 4 i's multiplied together, that equals 1. Okay, so why is that helpful? So in this particular case, what we're going to do is we're going to say every time we get 4 i's together, that cancels out to be 1, and it does not, it basically equals 1. So what does that mean? So if I've got I to the 15, let's see, 15 is equal to 4 plus 4, that's 8, plus 4, that's 12, plus 3. Double check my numbers, but I think it's correct. So that equals I to the fourth, I to the fourth, I to the fourth, I cubed. I to the fourth is 1, I to the fourth is 1, I to the fourth is 1, and I get I cubed. So again, this has to do with that cyclic or cyclical nature of I, that when you multiply i's times each other, you get some really interesting results. And so basically, since we're going around in a circle, every time we get to 4, we kind of don't count that. That won't change. That just becomes a 1. So it doesn't change our product. The product really depends on what the leftover bit is. So when we divide 4 into 15, it goes 3 times, and we've got a remainder of 3. That remainder is this number right there. So if we can figure out what the remainder is, then we don't have to do all of this math. Now, we do have to do one more thing, and that is, this is I cubed, right? And that, if you recall in the previous video, we were talking about I squared. Remember that I squared is -1. So this is I cubed is I times I times I. So any 2 of those i's is I squared, and that's a -1. And we have to convert that. So we get the opposite of I. So we get this really interesting kind of math where we start out with I to the 15th, but instead of getting like bigger and bigger and bigger and bigger, it just goes around in that circle. Now, to be honest, you could also use the circle. What do I mean by that? I mean that if you really wanted to, let me get a piece of paper. If you really had the time, if you don't like doing this math, you could draw that circle for yourself. Here I've got I. Here I've got I squared. Here I've got I cubed. Here I've got I to the fourth, I to the fifth, I to the sixth, I to the seventh. Oops, we're going to Smeary Town. Sorry about that. I to the eighth, I to the ninth, I to the 10th, I to the 11th, I to the 12th, I to the 13th, I to the 14th, and I to the 15th. Woohoo! So if you go around in a circle and you count them off, you get to I to the 15th here, and I cubed, which is I times I squared, which is the opposite of I. And then I squared, remember, -1, and I to the fourth is 1. So if you wanted to, you could just sit here and count off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and we'd be here. And that would be our answer. So that's another way to do it. You could do it that way. Okay, so let's simplify. I to the 16th. 4 into 16 goes 4 times. It goes evenly, so my remainder is 0. So that means that I to the 16th is equal to I to the 0th, which is 1. If you're not sure about that, you're like, Oh, that was weird. That was some magical stuff. It is kind of interesting stuff. Imaginary numbers, they really are wild. They're a bit of a trip. The numbers work in a slightly different way. We could count it off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We're at 1. Okay. Now, the thing is that modulo is going to be helpful because then you get a teacher who thinks that they're so funny and they give you a number like 37 and you sit there and go 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I'm so tired. I don't want to do this. So if the numbers get too big, I'll remind you, you could do 37 mod 4, or in other words, 4 into 37. You got to think, okay, 4 into 37 goes 9 times, because 9 times 4 is 36. And that remainder is 1. So I to the 37th is equal to I to the 1st, which is I. Which is really wild, isn't it? Just because they go around in a circle like that. And then I could give you a stupid high number, like 102. And again, same thing. If you've got I raised to the 102 or 102nd power, 4 into 102. So here you just have to remember 4 goes into 100, or 4 goes into 10 twice. 2 times 4 is 8. You bring that down. You've got 22. That goes 5 times. And we've got a remainder of 2. So I to the 102 is equal to I squared, which is, what does that equal? Remember, I know there's a lot of smears over here, but it's got it. I squared is -1. That's the definition of the imaginary number, that I squared is -1, the imaginary constant. So that is how you use modulo, or remainders, to simplify powers of the imaginary constant, which I think is very cool. It's really okay if you don't think it's cool. I really appreciate you letting me show you that. So go take a nice break. The next video is on complex conjugates. You might want to practice with imaginary numbers a little bit before you go on, because complex conjugates get really complicated pretty quickly. So take a break, let your brain just absorb all of this, maybe do some practice, and then come back and see the next video. Woohoo, you guys are amazing. So incredibly brilliant. Oh, rock on, math on, and woohoo.